Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss about the flow control, how the TCP is going to maintain a flow control. Therefore, we are not going to see a concept of a condition. So, before entering into the details, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, we know Unacademy has created wonderful interface to serve the dedicated students. The content is developed by and developing by the top quality dedicated educators. This is all beneficial to student. So utilize this opportunity what the Unacademy is provided and see the top quality content with a top quality interface. And myself is Srinivasrao IS, having more than 15 years of experience in the GATE with the various subjects. Also had industry experience in the backend, that is a database side and a system side. Also had a good certifications in the database and Cisco and Red Hat Linux operating system. So throughout my journey of GATE, I taught in many premium academies with a high success rate. So many of my students completed their post-graduation from India's topmost institutions like IIT, NIT, Central Universities and IIITs. Dear friends, utilize this opportunity and see that you are going to get admission into an academy and settle in your life and see that your goal is going to be fulfilled. So because your goal is an academy's goal and see that once you join into an academy, then you're going to get a live lectures and live sessions, dedicated lectures, whatnot, everything you can able to get through an academy. So according to GATE and ESE concern, there are two programs, Plus and Iconic. So Iconic Batch is a unique program where you're going to have a Plus itself. Along with that, you're going to have 1:1 personal coach. So this is one of the unique program which is not there by anybody else. And once you become a live plus member or a subscriber, you're going to see that unrestricted access. So you can able to achieve, you can able to see that access everything which are there from an academy's portal. And dear friends, there are few kinds of subscriptions as like this. So 12 months, 18 months, and 24 months. Dear friends, apart from top quality content, if you use my referral code, then you see that you're going to get a maximized discount. So these are the final prices according to that. The current first and second, third year students can prefer for long-term 24-month coaching, and others second and third years can prefer this, and fourth years can prefer this. So better, my suggestion, better you go for up to 24-month subscription. And the other kind of subscription is Iconic, where you see that these are the prices and use my referral code to get the maximized concession on an academy. So after applying my referral code, then you're going to get these are the final prices. Dear friends, don't worry about the subscription amount and all. Without investment, there are no returns. So that's what I personally and strong believe. So you please trust an academy and the faculty members or educators, so that see that your goal is going to be cleared. And if you are having any doubts, you can reach us just filling this form. So fill this form so that Unacademy is going to direct a faculty member or educator who can able to clear all your doubts. Let's crack GATE CSE. Unacademy is successfully running all the CSE subjects on YouTube. So subscribe our YouTube channel, hit the bell icon for latest notifications and updates. I use my referral code to get the admission into Unacademy. Why to use my referral code? Apart from concession, you're also going to get my guidance. So because throughout my journey of 15 years, many of my alumni students who are settled in a topmost positions, either in PSUs or in campus, that means corporate companies. So that guidance, you're going to get do's and don'ts in the examination. So you want my guidance, please join under me using my referral code so that I can able to assist you throughout your examination. Now, today we are going to learn about TCP Flow Control policy. So let us see what is the meaning of a flow control. If flow control not happens, if flow control is not there, what will happen? So let us see one of the sample example. If flow control is not there, what is the problem? So there is a client and there is a server. Because I am talking about TCP. TCP mostly used between client and server architectures. Please don't forget that important point. That too, it is a what? Full duplex communication channel. Now you observe carefully like this. So the server keep on hitting the data to the client. The server keep on hit the data to the client, and what will happen? Client has got a certain limit. Client has got a certain limit. So once the limit is exceeded, that's it. You're going to enter into concept unable to digest point. It is also known as overwhelmed, also called as congestion. So why the congestion has come to the other side? Because sender keep on transmitting the data without knowing the capacity of the client. Then what will happen? Somewhere else up to the client can receive data up to the certain point. Once that point you are crossed, then you see that you're going to see a concept of overwhelmed. It is a concept of what? Congestion. So in order to avoid the concept of a congestion, there is a requirement of what? A flow control. However, data link layer is there. There is a concept of a flow control which you can able to implement through stop and wait sliding window. Here also the TCP is reacting in different way how you can able to keep flow control policy. So what is a flow control policy? There is a proper synchronization between the client and the server. So it is trying to see that balance data rate between your client and the server is the concept of a flow control. So dear friends, flow control balances the rate of a sender and creates a data rate according to the user's requirement. So TCP separates a flow control from its error control. So this is the concept. What is it? Last session I told you about pushing and pulling. What is the pushing and pulling? Without a request by the client, if sender keep on transmit the data, it is a pushing. What is the meaning of pulling? So we are going to give a request to the other party. Based on the request, the other party is going to reply. That is the concept of what? Pulling. So when you are having a pushing and pulling concept, so especially pulling concept, you are 100% implementing a what? Flow control policy. So according to this, so there is a sender who is trying to transmit the data, and there is a other guy who is trying to receive the data. Now you observe carefully. Application layer is nothing but a sender side who is transmitting the data to transport layer, and here also the transport layer is going to get the data from your other side transport layer. What will happen? This application layer at the other side is pushing the data, So messages are pushed to the down, and this guy transport layer is acting as a consumer here. Now you see, and the other side receiver received the data and it is trying to provide to application layer. Now few steps here are there. First step, application layer push the data to the transport layer, because unless the application layer provides the data to transport layer cannot able to send, we know that. And the second step is that the segments whichever are there in your transport layer are being pushed. Now this data will be handed over, the transport layer handed over the data to your application layer. And the fourth step, we will give acknowledgement that okay, I have received, you send me next segment. And that acknowledgement we will inform to the application layer, then application layer reacts once again. So this 1, 2, 3, 4, 5 steps are being continued as long as there is a data with the application layer at the sender side. This is what is the meaning of a what? Pulling. So whenever you are asking a concept of a pulling, then indirectly you are seeing 100% you are implementing a what? Flow control policy. So whenever you are having a flow control policy, 100% you never see a concept of what? Congestion. Please understand carefully. You never see a concept of what? Congestion. So that's why in this session we are learning in such a way that how TCP is going to implement a flow control policy, and there are certain problems also are there. We are going to discuss those problems in the today's session. So please be learned quickly. Very important concept as we are learning advanced computer networks, especially in the TCP and UDP concept. So in order to implement your flow control, TCP maintains two windows. One is at the sender side, known as a congestion window. The other one is at the receiver side, known as advertise window. So congestion window is at sender side, advertise window is at the receiver side. As I am telling you pulling concept, what is the pulling? The producer cannot able to send the data to the consumer unless until there is a request. So the producer I cannot able to send the items to your consumer unless and until there is a what? A request. For example, this consumer requests that I need some data. So upon the request, the producer is going to transmit the data. Therefore, he is transmitting the data, whatever the elements are there at the producer side. So that data he is transmitting in the form of what? Segments. So he transmitted a segment here. Then client will take that segment and handing to your application layer. So as soon as the data is being processed by your application layer, again we are going to give our feedback that yes, I have received my data using positive acknowledgement. So this is the ideology. So in order to implement this, sender is maintaining a congestion window known as a CWND. A receiver is maintained AW, which is called as RWND. Nothing but receiver window. So congestion window and receiver window. So what is the ideology here? Please understand. So when you talk about the congestion window, so TCP stores the data it wants to send and keep it in the buffer. So TCP uses sliding window protocol to control the number of bytes to be transmitted in the transmission. The sender window can shrink. If receiver defines that I need only this much of data, then sender window is going to be shrink. And receiver window that result in a shrinking the window. So sender has to follow, there is a one important equation, that is a minimum of congestion window and the receiver window. Don't forget that. So very important question. Minimum of congestion window and receiver window. Why? I will show you. Now what is advertise window? It is called as a receiver window. So TCP informs to the other particular producer that I want this much data only. Whatever the request is given by the receiver, that much amount of data only sender must have to send. He cannot send more than a single byte what the receiver is not expecting. If he send, it leads to a concept of what? Congestion. So TCP allows the receiving process to pull the data on its own. So this means part of the allocated buffer at the receiver may be occupied by bytes that have been received and acknowledged. So the receiver window size is then always smaller than or equal to your buffer size. So what is an idea? Now come to the point. So please understand this analogy carefully. So application layer at the producer side, producer is nothing but sender, and a transport layer. Transport layer has got certain buffers. Consumer application layer, we want to hand over the data through your transport layer. So the receiver window has got some buffer space, and the sender window also is going to maintain a window with some buffer. Now listen, this application layer pushed some data to the transport layer of the producer. Let us say 0 byte to 99 bytes. So right now they are in the buffer. Please understand. They are in the buffer, then what they are going to do? So it is ready to send. So segment 0 I pushed, which consists of 0 byte to 99 bytes. So now those bytes of data is available in the buffer because there may be a chance that any of the segment may be lost or any of the byte is going to be lost. So you please maintain them unless and until you get a what? Positive acknowledgement. Now the consumer side, if you look at, so this segment 1 has arrived at the other side, segment 0, which consists of 0 byte dot to 99 bytes. What will happen? If the transport layer takes the data from your buffer and try to upload to your application layer, thus, as soon as all bytes are processed, after processing of all your bytes, then the receiver window has got, please see, when first byte of data is handed over to the application layer, you got 1 byte space. When second byte is pulled by the application layer, you got 2 byte space. When all bytes are pulled by your application layer, you got completely 100 bytes free. So as soon as you got 100 bytes free, then immediately the other guy will give you a feedback that yes, I have received. That means what? The consumer side application layer pulled all the 100 bytes from your transport layer buffer. Now the transport layer is got what? Free. Therefore, it is giving acknowledgement in such a way, I want S100. Why S100? Your acknowledgement is always +1 to your last byte successfully received. Here the last byte successfully received is a 99. So he is asking that I need S100. Now again, in the meanwhile, the producer process is going to consume some data because in the meanwhile, so till you get the acknowledgement from the consumer, producer is going to accommodate some data from your application layer and it is what? Coming into the transport layer at the producer side. As soon as upon acknowledgement has come, then immediately the producer is release the data. So that's why he is accumulating the data at the producer side. So transport layer at the producer side is trying to accumulate the data from application layer. So this is what is the concept of pulling, especially where we are using the flow control policy. What is the problem here? How sender window is going to be shrink and expand, I will show you. Now listen carefully. So I'm going to draw a big diagram. Please Step by step you understand. So there is a producer, nothing but a sender, you guess, and application layer is there, and a transport layer is there, consumer, application layer, and your TCP is going to hand over the data to application layer. Now you see, so any doubt please post me, I will discuss. So first initially some of the bytes have come from producer side application layer to transport layer. How much? Let me say 0 byte to 99 bytes. Now the segment is being pushed. Segment 0, because your first byte number is your segment number, which consists of 0 byte to 99 bytes. Now okay, perfect. The consumer side, the transport layer receives this. So how much data he received? 0 byte to 99 bytes. So your window is completely full there. There is no buffer space with you. It's completely filled. Now here what happened? So application layer start consuming. Application layer start consuming or pulling. Application layer is a pulling. Now for example, 0 byte completed, 1 byte completed, 2 byte completed, and so on. It is consumed only up to 49 bytes. So it is slowly consuming, not that much faster. So here timeout is going to happen because every segment is associated with a what? A timer. If you not give a reply within the timeout, then sender is going to retransmit it. That's why I want to give acknowledgement. So he is giving acknowledgement that yes, I have received your S0, but unfortunately my self application layer is only pulled 49 bytes. So your window right now at the consumer side is what? Only 50 bytes free and 50 bytes what? Already filled. And now we will inform to the producer process such a way that I have received last time 99th byte, so I am requesting that S100. But you don't send me 100 bytes of data because my buffer space is my buffer. Receiver window is nothing but a what? Receiver window is nothing but your total buffer size minus number of bytes to be pulled. How many bytes to be pulled? 50 bytes to be pulled. Please understand. 50 bytes to be pulled. So therefore, your receiver is not going to ask what? Your 100 bytes. He is advertising only, I need 50 bytes only. This is how he advertising. Now what will happen? The other side, he is going to transmit how much? S100 segment. Only 50 bytes only he will advertisement. Starting number is 100 and ending number is 149 as you asked only for 50. Then therefore what happened? Continuous diagram. Therefore what happened? In the second phase, already some of the bytes to be pulled at the consumer side. So if you understand, this is at the application layer and the transport layer. So you got received S100 segment which consists from 100th byte to 149th byte data. Now earlier we are having those data have to be pulled from what? 50 byte to 99 byte. Now recently these data is also has come. So now they are being placed into your window. Now what will happen? This is your latest one, 100 byte to 149 bytes I have received. Now the application layer is a start consuming. But you see, in the meanwhile, I need to give the acknowledgement. Then what is going to happen? So your receiver window size is a completely is what? Busy with the data. There is no free space at all because completely your buffer is filled. Then I will give acknowledgement to other party that. So I will give acknowledgement to other party that I have received your previous segment, otherwise he is going to retransmit it because it is been what? Segment is associated with the timer. So immediately he will give acknowledgement that yes, I have received your previous segment. The data I have received up to 149. Next byte I am expecting 150. But don't advertise anything here because it's completely what? Busy. It's no single byte is pulled by your application layer. Therefore, what will happen? You are advertising how much? 0. So when you are advertising 0, actually how it is shrinked, observe carefully. Initially, I started activity with 100 byte, then you made me to shrink. Second phase, I have pushed only how much? Only 50 base. And now in the third, my window is being shrinked to 0 bytes. So whenever sender receives a 0 byte acknowledgement segment, then immediately sender has to stop. Sender is going to be blocked because receiver advertised no bytes of data. Therefore, I need to stop till his data is pulled by application layer at the consumer side, so that he is going to get some buffer, and so that I am going to expect a what? Acknowledgement after some time. So this is the concept how the sender window is going to be shrink. So how the sender window is shrink? In first phase, let me give you a summary here. Producer, application layer, transport layer. First phase, he pushed 100 bytes of data. Please recollect it. Then in the second phase, he pushed only 50 bytes of data. In the third phase, he pushed how much? Nothing, 0 bytes of data. So this is how the producer side window is completely under the control with the receiver. So who is deciding the sender's window size? Sender window size is decided by receiver only. That's why sender is following such a rule. What is the rule? Minimum of my capacity, comma, receiver capacity I need to follow. Earlier both the capacity is fine, but in the next attempt what will happen? My capacity is 100 bytes, but he is asking only 50 bytes. That's why I pushed only 50. In the next time what will happen? My capacity is 100 bytes, but his capacity is 0 byte. Therefore I am going to transmit only what? 0 byte, which means myself is a block upon receival of 0 byte advertisement window. Upon receival of 0 byte advertisement window. So 3 iteration. First iteration, this is the capacity. Second, this is the window size of a congestion window. I am talking about CWND. So third, you are completely blocked. You cannot able to transmit a single byte of data because you are completely under the control of what? The receiver side. So that's it, friends. This is how you can implement what? Flow control policy. Every time we hit the center that don't send, or only send this much, or only send this much. So this is how we are going to control the sender. So let us see. As I told you, the receiver window size determines the number of bytes that the receiver window can accept from the sender before being overwhelmed. Therefore, what do you understand? The receiver has got a pakka control on the sender's capacity. How much you ask, that much only he will send. That's why don't forget this rule. What is that? Minimum of CWND comma AW. AW is nothing but receiver window. CWND is nothing but what? Sender window. So finally, very important equations I am discussing now. Compulsory question this is. So how you decide that what is the size of the receiver? The size of the receiver window, because the sender is ultimately controlled with the receiver only. As the receiver asks, that much only sender is sending. So now you decide how much receiver can able to ask the sender. So you need to see that the receiver window capacity first of all. How it is to be done? I am explaining like this. So your receiver window is nothing but the transport layer TCP total buffer size minus number of bytes are waiting to be pulled by your application layer. For example, you see, I already shown you in the previous slide, receiver window capacity is 100 bytes, but unfortunately 50 bytes are baki which to be pulled by your other side. So I got only how much space? According to this formula, receiver will advertise to the sender in such a way that don't send full of data. I am requesting you how much? I have got only 50 byte space. So I am giving you a positive acknowledgement by advertising that I want only 50 bytes. So why? Because your receiver window size is nothing but your total bytes, total buffer size minus number of bytes are waiting to be pulled from your window. So once after application layer pulled, then you got a free space, then you can able to advertise. So here you please understand. Fine, issue. I'm fine. So now you understand. There are few sentences I am specifying. Last byte received minus last byte read is less than is equal to receiver buffer. And receiver window is nothing but this is one of the equation. This is also another style of equation. What is that? So receiver buffer minus last byte received minus last byte read, same. So here and here is the same. So receiver buffer minus last byte received minus last byte read. Okay. So you can also say like this. A last byte sent by last byte acknowledged must be lesser than is equal to receiver window. These are all the equations which are speaking the same sentence but in different style. So ultimately receiver window is nothing but your total buffer size minus number of bytes to be pulled. So that's what I kept in a different kinds of equations. So you want me to discuss any of the equation, I can discuss how you can able to decide a receiver window as like this. Receiver buffer minus number of bytes to be pulled. How do you know that number of bytes to be pulled? Like this. Number of last byte received minus number of last byte read. So dear friends, so finally the receiver window is being calculated using this equation. Okay. So please look at here an example. So next byte to be pulled by the process is a 201. Next byte to be pulled by the process is what? 201. But I have received some extra data. Please understand, I have received some extra data also. So this is what is the extra byte, last byte I have received. So now you decide. This is your last byte read is a 200 and last byte received is a 260. So 260 minus 200 is your window size. Actually it is a capacity of something like 100 bytes if I say, but already 40 bytes are ho gaya, but baki is in the waiting to be pulled. So how much waiting to be pulled? Like this. What is that? This is the next byte to be pulled by the process. And in the meanwhile, I have received some other bytes also. The byte last number which I received is a 260. So 260 minus your 200. So still you are having a what? 60 bytes to be pulled. So your total bytes, your total buffer space minus your number of bytes to be pulled is a 60. So the client can able to receive only 40 bytes of data. So this is the concept. So for example, let us say S0 I am sending, which consists of 0 byte to 99 bytes of data. Observe carefully. First step. So I am talking about TCP only. So immediately application layer pulled 50 bytes. From where to where it is pulled, please understand. 0 byte to 49 bytes it is pulled. So still in your window consists of what? 50 byte to 99 byte. Please understand carefully. So next byte to be pulled by your application layer is 50th byte only. So in the meanwhile, because the timer must not expire at the other side, so I am raising an acknowledgement that yes, I have received data up to 99 bytes and I am giving positive acknowledgement for S100. How much you are advertise? This is very important. How much you advertise? Your total capacity is 100 bytes minus how many bytes to be pulled? How many bytes to be pulled? Only 50 bytes to be pulled because 50 bytes is already completed. So 50 bytes to be pulled. Hence, it is going to advertise that I need only 50 bytes only. Because the total buffer receiver window size is nothing but total buffer size minus number of bytes to be pulled, right? So in the event, next, the guy producers transmitted S100, which consists of next byte 100th byte to, as you requested only 50 bytes, 149th byte I have pushed. And what is happening? See the buffer space like this. The next byte to be processed by application layer is a pointer is here. And I have got received the data. How much? Continuously. I have got received data up to 149th byte. Some are in the old segment and some are in new segment. Now you tell me, what is your receiver window size? Your receiver window size is how much? Your total buffer size, that is nothing but 100 bytes minus number of bytes to be pulled from here to here. So number of bytes to be pulled is 100 bytes. So right now your window size is how much? 0 byte. Otherwise, last byte received minus last byte read. You can also use that equation. Please understand. What is the equation? Last byte received minus last byte read. What is the last byte read? Understand. Last byte read. What is the last byte read? 49th byte. What is the last byte received? 149th byte. What is the difference? Your difference is that much. What is the difference? Receiver window is receiver buffer minus last byte received minus last byte read. It is nothing but almost all 100. So receiver window is 100 minus 100. It is a what? 0 bytes. So this is how you are deciding the receiver window. Based on receiver window, the sender depends because he has to send you minimum of CWND comma RWND. Clear, friends? So what is the last byte read? I am giving you explanation. The number of the last byte in the data stream read from the buffer by the application process. Last byte received, which I have received. The number of the last byte in the data stream that has arrived from your network and has been placed in the receiver's buffer. So for example, so one of the very good question, this is the model question of your GATE examination. So receiver is a decider how much to send by the sender. Please understand that. So receiver window size, what is the value of the receiver window size for a host A, and host B has the buffer size of 5000 bytes, and in that 1000 bytes are unprocessed data. Now you know what is that? 5000 byte is my buffer capacity, but in that how much to be unprocessed? 1000 bytes to be unprocessed. Therefore your receiver window size is nothing but a what? Your buffer size, that is a 5000 bytes minus number of bytes to be pulled is 1000. So you are advertising how much to him? I am advertising only how much? 4000 bytes of data. So this is how you decide what a receiver window. So based on your requirement, the sender is going to reply with only that much data. Next question. So what is a silly window syndrome? So I'm expecting this year question on silly window syndrome, because not given so far in the history of the GATE examination, silly window syndrome. But we may guess because the question paper is going to come from IIT Mumbai. So let us expect a question. Very easy to solve, don't worry. So I'm going to give you clear explanation. Please understand. What is the silly window syndrome? It may happen at sender side, producer side. It may also happen at receiver side, nothing but consumer. There may be a chance, either maybe at producer or maybe at a receiver, or sometime both it is going to be happen. So if silly window problem is occurred, then the efficiency of the sender is completely drastically down. That's why we want to solve the silly window syndrome using some kind of solutions. So sender side solution is a different and receiver side solution is a different. So sender side solution is provided by Nagel and receiver side solution is provided by Clark. So two different authors have given a solution to avoid a silly window problem. So what is a silly window? If a sender side TCP window is transmitting very minute amount of data, then it is a silly window. Example, 1 byte at a time. So if a TCP of sender is sending only 1 byte at a time, you see that every 1 byte data you are consuming how much? 20 byte of TCP header and 20 byte of internet header and 18 bytes of data link layer header and trailer. This is a very costly matter. For every 1 byte you are spending this much of overhead. That's why the sender side efficiency is going to be drastically down because of overhead is a fixed. Even you send 1 byte of data or even send 60,000 bytes of data, I don't mind. The overhead is fixed. So let me discuss. For example, you see transport layer at the producer is releasing a segment consists of 30,000 bytes of data. So he is asking what are the headers you are trying to attach. First header to this 20,000 bytes of data, 30,000 bytes of data. The first header we are going to attach transport header. And the next header in the internet layer, you are going to attach internet header. And the next header and trailer you are going to attach a data link layer header and data link layer trailer. Therefore, what is going to happen? As per encapsulation we are doing. So you got a payload portion like this, which consists of TH and your 30,000 bytes of data. And here I am attaching a DH, data link layer header, to this payload. Header, and here also header. Here 30,000 bytes of data and a trailer. Now, how much the media is carrying, that's important. So, by default headers I am taking, it is a 20 byte and it is a 20 byte. It is a 14 byte. It is a 4 byte. Therefore, what is your overhead? Your overhead is internet header, transport header, and your header and trailer of data link layer all together. It is a 58 bytes. 58 bytes out of 30,000 bytes of data. So what is your link efficiency? Your useful is a 30,000 bytes of data, and your total you are transmitting 30,058 bytes of data. It's a perfect, very good efficiency you are going to get, above 90%. If I give you a scenario, please understand, if I give you a scenario that, so producer is producing data, only 1 byte only I am producing. That means the application layer at the sender is very slow to push the data to transport layer. Application layer construction is very slow at the producer who is trying to produce and dump the items to your TCP is very slow. Slow process construction. I am talking about application layer only. So, how much you assume? Only 1 byte at a trip. 1 byte at a time. Right? Then what will happen? The transport layer is a by force is a sending how much? Your 1 byte data. So you are going to transmit data vertically. Therefore, what will happen? To this 1 byte of data, you are adding your header, no doubt. And internet layer is going to add its own header, no doubt. And your data link layer is going to add its own header and its own trailer. And what will happen? How much is the header size and how much is the overhead you are utilizing? Same story, but here your overhead is a fixed, efficiency is going to be down. So this we discuss as a 20 byte, this we discuss as a 20 byte, this we discuss as a 14 byte and 4 byte. So all together, what is your overhead? Same 58 bytes only. So for 1 byte of data, your overhead is a 58 bytes. Then what is your efficiency? Your useful day only 1 byte of data, but I am sending a 59 bytes. So your efficiency is a point not. So this is the one of the big problem challenge at the sender side. So who is the victim in both the cases? Either sender side silly window syndrome or receiver side silly window syndrome. The ultimate effect on sender side only is the victimized, his efficiency is going to be the down. Because sender window is decided by the receiver window only. Don't forget that rule. Sender window is determined by the receiver window, minimum of CWND, RWND. Therefore, in both the silly window, the sender is going to be the victimized. His efficiency is going to be drastically down because for every 1 byte of segment, you are consuming almost all how much? 58 bytes of header and trailers. So, silly window syndrome is nothing but if a segment carries very small minute amount of data, that window is called a silly window. So whenever a transmission window carries a small amount of data, it is silly window. So therefore overhead and it reduces efficiency at the producer side. So silly window problem can occur in the two cases. One is sender side, the other one receiving side. How? Sender application layer is constructing data slowly. Receiver application layer is consuming data slowly, pulling data slowly. If consumer side is also pulling, you are advertising only 1 byte. If producer side is construction is very slow, you are going to transmit only 1 byte. In both the cases or either of the cases, you will find a silly window syndrome. So let us see the first case. Silly window syndrome at the sender side. So sending TCP may create a silly window syndrome application program that creates what? Data slowly, one byte at a time. And that one byte is coming from your application layer and dumping one byte at a transport layer. Therefore, by default, by force, transport layer has to send only one byte. Your efficiency is down. And the receiver side. So suppose application layer of a sender is very faster. Is constructing very speed to the and dumping the data to transport layer, but receiver is not that much faster to pull the data from the receiver transport layer. Therefore, here is the condition. What is that? The sender is a superb, but receiver is a very slower. The receiving application program consumes the data very slowly. Therefore, what will happen? He is raising a problem that every time he is going to advertise that I got only one byte buffer space. Therefore, you need to send by force only one byte. Again, the sender is going to be victimized. And case 2, receiver side. Flow control policy. What is the flow control policy? Initially, I have received 1000 bytes of data. Assume. So I have got 0 byte and dot to 99 bytes. So only one byte is pulled, so that your buffer space is consist only one byte. If the buffer at the receiver side is full, it advertises a window size 0, which means the sender should stop sending what? Data or one byte segment. So therefore, my dear friends, silly window syndrome may come either at the sender side or at the receiver side or both parties. Both parties means application layer at the sender is very slower and application layer at the receiver is also very slower. So both are going to expect and transmit only one byte of data at a time. So GATE NAT I already explained in the backbone. Please recollect backbone lecture. So NAT is nothing but network address translation. I already discussed in the routers concept. Please watch previous video, my dear friend. So what are the solutions to silly window syndrome? The solutions to silly window syndrome is nothing but what? Two authors have provided so that the sender is not going to be victimized. He is going to use a fruitful efficiency, not the meaningless efficiency. So sender side solution is a what? Nagel's algorithm. And receiver side solution is a what? Clark solution. So Clark has given two solutions. One is immediate acknowledgement, the other one delayed acknowledgement. The maximum time of delayed acknowledgement is a 500 ms. You can sustain not to send the acknowledgement up to 500 ms, but if timer is expired, then you have to give a what? Acknowledgement. Up to lesser than is equal to 500 ms, you can able to delay the acknowledgement without using immediate acknowledgement. So let me explain what is a Nagel's algorithm. So this is the solution to prevent a silly window problem at the sender side. So Nagel is saying that, listen, let me give you an overall idea. So producer side application layer, we guess that it is a dumping one byte to TCP at the sender. Right. Then TCP first segment he will push. Rule number 1. First segment he will push with what? 1 byte data. Because I got dumped only 1 byte from my application layer. Now, don't send immediately next segment with 1 byte because your efficiency is going to be very poor. It's nothing but your efficiency is 1 byte divided by 59 byte as I take an example. Now, first step is send 1 byte segment. Second step is don't send immediately next segment. Wait a decent amount of time. Wait a decent amount of time such that the window might be filled. the window, two cases. The congestion window might be filled completely because you are waiting now. You are not sending immediately data. Might be filled completely or at least half of the window. This is what is our task. So what will happen? Instead of sending a 1 byte, we are very clever. What to do? So we are waiting according to that. The TCP module of sender side is waiting and see that every time one byte is a dumping. So you are waiting till such an amount of time that at least your buffer is your buffer is completely filled or at least half of your window is filled. So when you are sending half of data, then at least your efficiency is going to be good enough and fair enough. So according to that, what will happen? I say my capacity is something like 1000 bytes of data. Instead of sending one byte, I will wait till my buffer is completely filled or at least 500 bytes to be filled. In that case, what is your efficiency? My efficiency useful, at least I able to transmit half of my total window size divided by your total. How much? 500 bytes plus 58 bytes is a fixed. Don't forget that. So your efficiency is somewhat better in this case. So two steps given by Nagel for the sender side silly window prevention. First step, TCP sends the first byte of data. Second step, don't send immediately next byte of data. Wait a decent amount of time. After sending the first segment, the sending TCP accumulates data in the output buffer and waits until you get a proper acknowledgement from other side or until enough data is accumulated to fill a maximum segment size. Enough data in the sense either completely or at least half. Either completely or at least half. That's it. So this is how you can able to enhance the efficiency at the sender. Earlier, before Nagel algorithm, it is a 1 byte divided by 59 bytes. This is your efficiency. After Nagel algorithm, your efficiency is somewhat better, at least half of window divided by at least half of the window divided by your total data. Half of window that data plus your 58 bytes of overhead. Now let us see Clark solution. So advantage is simplicity. So the application program is faster than the network segment. Then you can able to send up to MSS. If application program is slower than the network, the segment are smaller, then you send the less than maximum segment size, which is nothing but half full. Now let us see Clark solution. Very important solution, Clark. So Nagel solution is different from Clark solution. Clark has provided two solutions. So let me give you a diagram for Clark solution. It is immediate acknowledgement. First solution is immediate acknowledgement. So how we are controlling sender, please observe carefully. Therefore, sender is not going to be victimized and his efficiency is not going to be fallen. How? Let me show you. So sender side application layer is very faster because now I am talking about receiver side is very faster. Fast dumping or fast construction of TCP data. But unfortunately, the receiver, that is a consumer, is a slower consumption. From your transport layer. Pulling is very slow. slow consumption. So how much consumption you are doing? According to our example, 1 byte at a time only. Same. There 1 byte at a time construction, here 1 byte at a time consumption. Now what will happen? So first, the sender has transmitted, as he is a very fast constructor. So he is sending some data up to 100. Let us say his capacity is 100 bytes. Please analyze what I am saying. So he is releasing S0 segment with 100 byte of data, no doubt. So that 100 bytes of data is arrived at other side. 0 byte is a starting number, ending number is a 99 bytes. Now, receiver side application layer consumption is very slow. Only 1 byte only is taking away. First byte is been got. So you got only 1 byte free space. Please observe carefully. So 99 bytes still full. Only 1 byte you got room because only 1 byte consumed. So immediately what we are doing? We will give a request that please send me S100. How much data? Only 1 byte. Because your capacity is only 1 byte, then the sender is unfortunately, because sender window size depends on your receiver window size, he will follow my capacity is 100, but the receiver is asking only 1. So I need to send only 1 byte only. So when you are sending a 1 byte segment, very poor is efficiency. 1/59 you are going to get. That's why to avoid this problem, Clark is given immediate acknowledgement system. What is immediate acknowledgement system? Observe. So producer, fast application layer construction, and data is dumping to transport layer. Fast construction. Okay, and his buffer size is 100 bytes capacity. He can send at a time. But consumer is a very poorer, slow consuming. Application layer is a slow consumption, because unless application layer consumed, you cannot say that you are received the data for a corresponding process. It is also very much important. So the data has to be given by transport layer. Don't forget that. Application layer at the consumer pulled the data from your transport layer. Now first he pushed S0 with 100 byte data, no doubt. Then other side he received, his capacity is also 100 bytes only, 100 bytes capacity, don't forget that. Assumption, these are all. I got received 0 byte dot dot to 99 bytes. So anyhow he pulled only 1 byte. 1 byte pulled. So you got immediately 1 byte gap, right? You got only 1 byte gap, still 99 bytes are filled. So according to previous example, I have given advertisement window that only 1 byte, but this time I don't give. What I am going to do? I will give acknowledgement that I want S100, but I am not advertising this time 1 byte. I am advertising how much? 0. So when you are advertising 0 bytes, then what will happen? Then sender understand that you are not asking anything. Therefore, simply I will be blocked. Simply the producer is going to be blocked. How long you will be blocked? See that his efficiency is not going to be fallen, but delay is there. Don't forget that. His efficiency is not going to be fallen, but delay is there. You yourself made him to sleep, so yourself has to wake up. How much time? So after some time, receiver got some buffer. Receiver got some buffer. And now we will give a wake up call to him such a way that same segment I am sending this time. So because of this segment I made him sleep. So I am giving S100. Now I am advertising some meaningful amount of data because I got some buffer. So as and when you get this, now the sender is going to be wake up. He is going to be unblocked. Then he will send 100 bytes of data. That's it, friends. A wonderful solution given by the clerk with the help of what? Immediate acknowledgement. But there is a delay. Why there is a delay? You blocked him, and the receiver side consumer, that means application layer has to consume the data. Then you have to wake up. It is going to take some time. That's why immediate acknowledgement has got two problems. One problem, deadlock chance, and the other problem is a what? A delay at the producer or sender side. That's why we are not going to take this. Let us see immediate acknowledgement. So send an acknowledgement as soon as you got 0, and if you are not having a buffer, immediately send a segment with advertisement of 0. So until either enough space you get accommodate, until at least half of the receiver buffer is empty. Please don't forget this half rule. Until receiver buffer is got empty. Therefore, the receiver advertise with some good amount of data, then sender is going to send that good amount of data. So his efficiency is going to be at least meaningful instead of 0, 0, 0. So disadvantage, chance of deadlock. And delayed acknowledgement. So delayed acknowledgement means what? In order to avoid the deadlock situation, then Clark has given another solution, that is delayed acknowledgement. It's very simple. What is that? Now directly I am focusing on to consumer only. So 1 byte only it is a pulling. Okay, let it pull. Still, so I got only 1 byte free space and 99 bytes are still filled. Now don't give immediate acknowledgement because there may be a chance of deadlock. I will explain in the timers concept. So here what I am going to do, I am going to start a delayed timer. I am going to start a delayed timer, and this timer value lesser than is equal to your retransmission time, your lesser than is equal to your timer of sender side. Please understand, because whenever sender releases some segment, he is going to start a what? Timer, and this timer value delayed timer must be lesser than is equal to your normal timer. Otherwise he is going to retransmit. He may think that this gone because there is no response from you. That's why delayed timer I use. What is the advantage of delayed timer? The advantage of delayed timer is nothing but as I am making late, so that the receiver side, the consumer is going to pull some kind of data. So during this delayed timer, during time of delayed timer, receiver application layer can pull good amount of data. That's it. When it pulled some good amount of data, then you are going to get some free buffer space. After that, I am going to give advertisement window, at least something like S100. So I am advertising at least, if not full, at least something like 50 bytes or 80 bytes out of your total buffer size. But don't forget that as soon as the delayed timer is expired, you have to give acknowledgement. Don't wait more than your lesser than is equal to 500 is your time. So beyond that, you should not wait, because there may be a chance that the timer is going to be expired, then he is going to retransmit it. So the maximum time to your delayed timer is how much? 500. So this means that when a segment arrives, it is not acknowledged immediately. We will wait him. The receiver waits until there is a decent amount of space in the incoming buffer before acknowledging what? Arrived segment. The delayed acknowledgement prevents the sending TCP sliding its window. So advantage with delayed acknowledgement is what? It reduces traffic and avoid the deadlock concept, and you need not give acknowledge to every segment. But disadvantage is that 500 ms you can take, not more than that. but this is also very good amount of delay at the sender side. So the delayed acknowledgement may result the sender unnecessarily retransmitting what unacknowledged segments if at all it expire. For example, if your my timeout timer is expired at the sender, he will retransmit it. That's why there is a limitation in the delayed timer. You may ask me that how much time the sender is going to underwait. Yes, of course, it's not infinite. How much it is? It can be up to 500 ms only. So that's why in order to avoid this number of retransmissions because of the timer expires at the producer or sender side, it's now very clearly defined that the acknowledgement should not be delayed by more than 500 ms. You can start delayed timer, I don't mind, but you should give the acknowledgement just lesser than is equal to 500 ms. You can take it. After that, you're supposed to give what? Acknowledgement. So, my dear friends, you see once, what is the size of the window of A if the receiver window size is 3000 bytes and value of the congestion window is 3500? So what is the sender capacity? Sender capacity is a 3500 bytes. What is the receiver capacity? 3000 bytes. So your sender window size is always depends on your receiver window size because we are using a minimum rule. So minimum of 3500 comma 3000. So he is going to transmit only 3000 bytes of data. And the remaining question already I discussed. Sender window size is always decided by the receiver only. And receiver window size can be computed using what is the rule? Receiver window size is nothing but your buffer size minus number of bytes to be pulled. Number of bytes to be pulled. That's nothing but last byte received minus last byte read. So number of bytes to be pulled. So that's why so receiver buffer capacity is a 5000 bytes minus number of bytes pulled is 1000 bytes. So you can advertise him how much? Only 4000 bytes only. No, leaky bucket and token bucket solutions for internet layer, my dear friends. Leaky bucket and token buckets are only for internet layer congestion prevention. But here we are learning what? And tomorrow class we are going to learn how you can able to uh, avoid and detect the collision or control the collisions in TCP using AIMD algorithm. Additive increase, multiplicative decrease algorithm we are going to learn in the tomorrow session is very important. Don't miss compulsory gunshot question in the examination, right? 2020 also I think so there was a question, 19 also there was a question. So leaky bucket algorithm, token bucket algorithm, open loop and closed loop policies only for internet layer. But congestion control in TCP is only AIMD algorithm. Please understand. Two policies, flow control policy as well as AIMD algorithm. Together we are going to implement to prevent the congestion in TCP. Clear na? So tomorrow we are having congestion control. Don't miss sharp 7 o'clock we will make. Please thank you for all your support. Share all my lectures to all your friends, those who are far away and unaware of me. And please like every one of my lecture because lot of pain is there behind preparation of this content. And please give your valuable comments because nowadays what I mean to say, watching of lectures by students based on your likes and comments only. Please give your valuable comments. Therefore, your juniors are going to be watched because these lectures are lifelong. Will be in the YouTube. All credit goes to Unacademy because I am on behalf of Unacademy is providing entire content of database management system, operating system, and computer networks. So many of my students last 6 months in my training So the last 2 days back, one student gave me a message that he selected in Google. Really wonderful. So and to yesterday, one student from Chennai, he said that she selected in UGC Net. And today also, one of my students selected, one of my friend, he is also selected in UGC Net. Please share all these videos, give your positive comments. Stay tuned to Unacademy and stay tuned to my classes. Thank you very much.